equation. The formula for finding next equation. Know that next equation we're looking for the EMF, not the standard. Because there's difference between standard and just normal E. Standard EMF will have this zero on top, while normal EMF will just be this. It don't have anything. So this is EMF, this is standard EMF. This is also standard gives free energy. Standard gives free energy. Anything having not is standard. Why this is normal G. So the formula for next equation is E is equal to the standard EMF minus RT over NF log Q. So link Q, link Q. Or it can also be the EMF will be the standard EMF minus 2.303 RT over NF log Q. So you can either use this one or you can use this one depending on your calculator. This is in lean and this is in log. So you get the same thing if you use it. So what's our R? Our R, of course, is a constant, molar gas constant, which is 8.314. Our temperature is T. The temperature has to be in Kelvin and it will be given in the question, of course. Why this N is your number of electrons, your number of electrons, and F is Faraday's constant, and your F is 96,485 coulomb per mole. That's zero. So that's R, that's T, that's N, F. E is standard EMF, right? E naught is standard. E naught is standard EMF. So, but what's our Q? Q will be the concentration of product divided by the concentration of your reactants. That will be product over reactants. You should know that in chemistry, this stuff means concentration. This stuff here means concentration. That's why I put the bracket up. So that's our Q. Our Q is product over reactants. So let's solve one question on next equation and round up this video. So of course I'll project the question in the video so you can see it right there. Okay. So they said, let me erase this. So calculate the EMF of the cell. Then said they gave the cell notation, of course, that has to be given 0.1 molar. So looking at this now, if they tell you to find the EMF of this, if you just go ahead, maybe restructuring your equation and adding it up, you get an answer, but the answer will be incorrect because that's not how to go about it. Here they asked us to find EMF of the cell. How do you know we are to use next equation or not? You have to look at the concentration given. You can see that the concentration, they are different. So that means we use next equation. If they were to be same, we just go, that means they're asking us to look for standard EMF. But since they are different, we have to use our next equation. So that's why our next equation is applied in real life, not in standard processes, because real life application will always vary unlike standard application. It's just like your Van der Waal equation, how it's different from P is equal to NRT. So let's let's dive into it. Now, if you look at this, your cobalt is moving from plus one to plus two. Yes, it's moving from plus two to plus one. So then I need to restructure this stuff. But if you look at nickel, it's moving from plus two to plus two to plus one. That means it's still same. So let's just restructure this equation and do it. So when we restructure this, and we don't need to touch the electron because they are same. So when we just restructure this, that will be CO giving CO2 plus 2E minus. Our electrode potential is going to change in sign. So that will be plus 0.28 voltage. So the standard EMF, we're just going to add it up. That will be minus 0.257 plus 0.28. And that will give you 0.023. So we found the standard EMF, but not the EMF. This one is just the standard EMF. So to find the EMF, let's clean this. Okay. So we found the standard EMF. So to find the EMF, then we use our next equation, which is standard EMF minus 2.303 RT over NF log Q. So our standard EMF here is 0.023. There's 0.023. This is in voltage minus, that's 2.302. Our R is a constant, which is 8.314. And our temperature is 25 degrees Celsius. They give us. But we will not put it in degrees Celsius, it has to be in Kelvin. So we add 203, and that will be 298 Kelvin, all divided by our N plus 2. So has 2 electrons. N is 2 electrons from the equation that we saw earlier. So N is 2, that's 2 times F is Faraday's constant, which is 96,485. Then our log, our Q, I told you Q is the the product over the reactant, that's concentration of the product over concentration of the reactant. Concentration of the product over concentration. Now what's the product? The product is nickel. From the equation, you see that the product is nickel. The product is concentration of CO2 plus, yeah, concentration of CO2 plus, that's cobalt over the concentration of nickel. So the concentration of cobalt here is 0.1, while the concentration of nickel here is 1 molar. I shouldn't have rubbed off the equation, but it doesn't really. So this is 1 here, and this is divided by 0. Sorry, 0.1. That's for cobalt, divided by nickel, which is 1. So we just have to input this, and let's get the EMF 0.023. And let me just put this straight up. Okay. So here we are going to have everything here is given minus 0.0296. So since we've gotten this, we just have to solve for E. That's 0.023 plus, because of negative times negative is positive, so we have to add. That's 0.023 plus 0.0296, and that will give you 0.0526. That's 0.0526 voltage. So this is the EMF of the cell. So that's what next equation is talking about, and that's how to solve question on next equation. If you like the video and share it out. Thanks.